Okay, so let's review these problems. This is what we did last time, rationalizing the denominator. So on the first one, our problem is that we have the square root of 7 on bottom. We're not allowed to have the square root of 7 on bottom. So what do we need to multiply by? Square root of 7 on bottom and on top. Some people get confused and start doing like the square root of 3 on top and 7 on bottom. It has to be the same number on bottom and on top. So when I go to multiply this, 2 square roots of 3 times the square root of 7 is 2 square roots of 21 over the square root of 7 times the square root of 7 is square root of 49. And what is the square root of 49? 7. So it's 2 square roots of 21 over 7. And you can skip this middle step if you wanted to. You don't have to do that middle step. Okay, look at number 2. How do we rationalize a cube root? You do the same thing, but this time you have to do it 2 times. So I'm going to multiply by the cube root of 3 over the cube root of 3 once, and then do it again. Cube root of 3 over the cube root of 3 a second time. This solves my problem because on top I get 2 on the outside. Cube root of 3 times cube root of 3 is cube root of 9. On bottom, if you wanted to work it out, cube root of 3 times cube root of 3 times cube root of 3 is cube root of 27, and the cube root of 27 is 3. Another way to think about this is if I put them all together, 3 times 3 times 3, 1, 2, 3. I have a group of 3s I can now pull out, and I would get 3 on bottom now. So your answer is 2 times the cube root of 3 over 3. Questions about that one? Okay, for number 3, this is the one where you have to multiply by the conjugate. The conjugate in this case is the square root of 7 plus the square root of 5. You have to do that on bottom and on top. So on top, I need to distribute the 7 into the square root of 7 plus the square root of 5. 7 times the square root of 7 is 7 square roots of 7. I'm going to actually go to the line underneath this. 7 square roots of 7. 7 times the square root of 5 is 7 square roots of 5. On bottom, we have to FOIL it out. So the first one, square root of 7 times square root of 7 is square root of 49. Square root of 7 times square root of 5 is positive square root of 35. Negative square root of 5 times the square root of 7 is negative square root of 35. And negative square root of 5 times positive square root of 5 is negative square root of 25. Okay, so on top, can I combine those? Square root of 7 and square root of 5? No, because they don't have the same root. I can't simplify them, so you're done on top. That's all you can do on top. So it's just 7 square roots of 7 plus 7 square roots of 5 on top. On bottom, I can simplify it. What's the square root of 49? 7. What is positive square root of 35 and negative square root of 35? 0. It cancels. Minus, what's the square root of 25? 5. And so what's 7 plus 0 minus 5? It's 2. And that's your answer. If you could divide all your outside numbers by the bottom number, you would go ahead and do that. In this case, I have a 7 and a 7 on top and a 2 on bottom, and I can't simplify those. Questions about that? Okay, so I kind of went over this like at the very last minute of class last time, but we were right here on Wednesday solving radical equations. Friday, we are reviewing, and Monday is your third major quiz, okay? It feels like we just had one. We didn't have that much to cover before our next one, okay? So I have the review for you. I will pass it out for you in just a minute, and if you are on D2L, your review is posted under week 9 documents, okay? Also, just a heads up, there's a typo on this. It said the 28th. The 28th is Wednesday. So your major quiz is on Monday, and everybody needs to be here in class for that. Questions about that at all? Okay, let's go ahead and get started on our notes. Our last set of notes before the next major quiz is radical equations, 7-6. Okay, so radical equations, it's just an equation that has a square root in it or a cube root in it. So the way we solve equations with a square root or a cube root, we're going to solve just like normal. The idea here is that we just need to undo a square root or undo a cube root. How are you going to undo a square root? Multiply it by itself, which means squaring it, right? So I square a square root to undo it. How would I undo a cube root? Cube it, okay? So to undo square roots, to undo cube roots, you do the opposite. We square it or raise it to the third power. One weird thing about these problems is sometimes they have these things called extraneous solutions, and I'll show you what that means in a minute. Essentially, what that means is you just have to check your work. It means you have to check your answer on these, because every once in a while, a problem will not work out. You must check your answer. The reason why we have extraneous solutions on these problems is when we square a negative, it turns it into a positive, and then it seems like the problem could actually work out, but it wouldn't actually work out with that negative. So that's essentially the reason why you do it. Okay, so let's do a few problems. Let's start off with the square root of, let's start off real easy. X plus 2 equals 5. Okay, so let's talk about the things happening to X here. We have X plus 2. How are we going to move the 2? Yeah, we're going to square it first. But the way you'd move the 2 later on is to subtract it, right? We also have a square root. How do we undo a square root? Square both sides, okay? So the first thing I have to do is undo the square root. So I need to square both sides. On the left-hand side, the square and square root, they undo each other. So I'm just left with X plus 2. On the right-hand side, I get 5 squared. What is 5 squared? 25. And then how do you solve for X now? Subtract 2 from both sides. And I get X equals 23. Okay, so you got to check this. So here's our check. I plug it back into my original equation. The square root of 23 plus 2, does that equal 5? Yeah, the square root of 23 plus 2 is the square root of 25, and the square root of 25 does equal 5. So this is our answer. Okay, let's do another one. If I had the square root of 2x minus 3 equals 4. What's the first thing I need to do here? Yeah, get rid of the square root. So we need to square both sides. So the square root of 2x minus 3 squared, the square and square root undo each other. I'm left with 2x minus 3 equals, what's 4 squared? 16. How do I solve for X now? Yeah, move the 3 over. Sorry. Add 3 to both sides. We get 2x equals 16 plus 3 is 19. How do I solve for x? Divide by 2. It doesn't divide evenly, so you could leave it as 19 over 2. Or you could divide it out, and I got 9.5, right? Okay, you got to check it when you go to plug it back in. So here's my check over here. The square root of 2 times 19 over 2 minus 3, does that equal 4? So 2 times 19 over 2. I'm sorry, I'm a little sleepy this morning. The 2's cancel out, right? 19 divided by 2 times 2. The 2's undo each other, so I'm left with 19. So I get the square root of 19 minus 3 equals 4. 19 minus 3 is 16. Does the square root of 16 equal 4? Yeah, it does. So those answers work. Let me show you the one that where the answer doesn't work. Okay, so what if I had the square root of 2x plus 5 equals negative 3? In this case, get rid of the square root. So I'm going to square both sides. So I get 2x plus 5 equals negative 3 squared. What's negative 3 times negative 3? Positive 9. To solve for x, I'm going to subtract 5 from both sides. I get 2x equals 4. Divide both sides by 2. And I get x equals 2. When you plug this one back in, I get the square root of 2 times 2 plus 5. Does that equal negative 3? 2 times 2 is 4. 4 plus 5 is 9. Does the square root of 9 equal negative 3? Because negative 3 times negative 3 is negative 9. No. Okay. So the confusing part is when we have done, remember when we're putting the square root in the problem and we take the square root, we have to put plus or minus because there's 2 different scenarios that could work there. Did we put the square root in this problem? No, the square root already existed in the problem, right? So in real life, this is not true. The square root of 9 is not negative 3, right? And that's a little bit confusing because it's like when we're putting a square root in the problem to solve it, we have to put both situations. But in this case, like in real life, if you type this in your calculator, the square root of 9 is positive 3. It's not negative 3, right? So negative, when I plug in 2, this does not work. Okay, so this is a no solution problem because the one answer that could work doesn't actually work. And you could kind of look at it at your original problem when we wrote it down. The square root of something equals a negative number. It doesn't matter what the something is. The square root of something doesn't actually equal a negative number. Does that make sense? Okay. And the difference between this kind of problem and the kind of problem where we're solving where it's like x squared equals 9. In this case, if I plugged in positive 3, would that work? Yes. If I plug in negative 3, would it work? Yes. I put in the square root to solve it, so that's why I have to do positive or negative 3. The square root of 9 is still just positive 3. It's not actually negative 3. Does that kind of make sense? Okay, so if there is a square root in the problem that was given to you, you can't get negatives. If you use a square root to solve a problem, that's when you do the plus or minus. And I know that's kind of confusing. Okay, so if you get an answer that doesn't work, then your answer is just no solution there. Sometimes you get 2 answers. One answer works, the other doesn't. You would choose the one answer that works. Okay, so let's do some of those. Actually, before I do that, let me do a couple more problems before we get to that. What about if I had the problem of the square root of 3x minus 5 plus 7 equals 14. Okay, so notice here I have the square root of 3x minus 5. I've done a problem like that, but then I also have this plus 7. Am I going to square this first, or am I going to move the 7 first? You have to move that 7 first over to the other side. Get the radical by itself, and then you can square it to get rid of it. So subtract 7 from both sides. And I get the square root of 3x minus 5 equals 14 minus 7 is 7. Now get rid of that radical. Get rid of the radical by squaring both sides. Okay, so on the left-hand side, I get 3x minus 5. On the right-hand side, I get 7 times 7, which is 49. And then add 5 to both sides. I get 3x equals 54. Divide both sides by 3. And I get x equals 18. Plug it back in, make sure it works. It should work because it was a positive number here. So the square root of 3 times 18 minus 5 and then plus 7, does that equal 14? Well, 3 times 18 is 54. 54 minus 5 is 49. Square root of 49 is 7. And does 7 plus 7 equal 14? Yes. So 18 is the answer here. Okay, so what if, I'm going to go ahead and start on a new page for this one. What if I had a problem that looked like this? The square root of 4 minus x equals x minus 2. Notice I have x's on both sides here. Okay, the first thing you need to do is try to get that radical to go away. How am I going to get that radical to go away? Square both sides. Yep. So when I square both sides, on the left-hand side, it fixes my issue, but on the right-hand side, I get x minus 2 squared. Okay, so on the left-hand side, the square and square root undo each other. I'm left with just 4 minus x. On the right-hand side, how do I do x minus 2 squared? X minus 2 times x minus 2. And then you have to multiply that out. Okay, so x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. I can combine those two middle terms. Now we get 4 minus x equals x squared minus 4x plus 4. What kind of equation do I have here now? I have a squared. What do you do with squareds? Or what's a squared equation called? A quadratic, a polynomial, yeah. But specifically, it's a quadratic equation, right? How do I solve quadratics? Yeah, there's 5 options. We've gone over 3 of them in here. Factoring, quadratic formula, or square roots, right? This is not a square root problem. Let's either, if we're going to do factoring or quadratic formula, what do you have to do first before I can do either one of those? To be able to factor, it has to equal 0, right? To be able to use quadratic formula, it has to equal 0. So I got to get this equal to 0 first. So let me move the 4 over and let me move the x over. So I'm going to subtract 4 from both sides. And both sets of 4's cancel out. So I'm left with negative x equals x squared minus 4x. How do I move this negative x? Add it to both sides, plus x plus x. So I get 0 equals x squared minus 3x. At this point, you're either going to factor or use the quadratic formula. If I use quadratic formula, my a value is 1. My b value is negative 3. What's my c value? 0. You could plug it in. This actually factors a whole lot easier. This is just a GCF factoring problem, right? What's the greatest common factor with x squared and negative 3x? X. So I can pull out an x. What's left over when I pull out an x? X minus 3. Once you have it factored, how do you solve it? Set each factor equal to 0. So I'm going to take this x and set it equal to 0 and solve. Done, right? It's already solved for x. On the other one, x minus 3 equals 0. You have to add 3 to both sides, and you get x equals positive 3. So 0 and positive 3 are my two answers here. You have to check them and make sure they work. So let me go back to my original problem and check it. So my original problem of the square root of 4 minus x equals x minus 2. Let me plug in 0. 4 minus 0 equals 0 minus 2. The square root of 4 minus 0 is just the square root of 4, which is 2. 0 minus 2 is negative 2. Does 2 equal negative 2? No. So 0 is not an answer here. Sorry. Let me check it with the 3 now. 4 minus 3 equals 3 minus 2. 4 minus 3 is 1. 3 minus 2 is 1. Does the square root of 1 equal 1? Yeah. So x equals 3 is my only answer here. Questions about that? Okay, so that one was a little bit harder because I had an x on the other side. I ended up with a quadratic, so I had to solve it using either quadratic formula or factoring. Okay, let's look at a cube root problem. Cube roots are just as easy as the square roots one. If I had the cube root of x plus 1 plus 5 equals 3. First step here is to move the 5 over. So I'm going to subtract 5 from both sides. I get the cube root of x plus 1 equals 3 minus 5 is negative 2. How are you going to get rid of a cube root? Cube both sides, right? Raise both sides to the third power. So the cube root and cube undo each other on the left-hand side, and we just get x plus 1. On the right-hand side, what's negative 2 to the third power? Negative 8. And then how do I solve for x here? Subtract 1. And so I get x equals negative 9. You do not have to check your cube root problems. The reason why you don't have to check your cube root problems is when I take the cube root of a number, it's either negative or positive, and it's okay to be either one, right? You can check it. It's not going to hurt to check it, okay? So if you forget and you go ahead and check it, you're only just making sure you got the right answer. So if you checked it, you would get negative 9 plus 1 plus 5 equals 3. Negative 9 plus 1 is negative 8. The cube root of negative 8 is negative 2. And negative 2 plus 5 equals 3. Questions about that? Okay, so I'm going to pass out your review for your major quiz. Again, your major quiz is on Monday. The review is 5 bonus points on your major quiz if you want to participate in that. And if you're on D2L, your review is under week 9. If you have any questions, feel free to come ask. Otherwise, I will see you on Friday.